And our last example is actually quite helpful for AP Calculus. The composition of functions, it's important to be able to see when one function is inside of another function. And it is quite easy to see if you think of order of operations. The inside function is what you're doing first, and then your outside function is what you're doing next.
Thank you.
You're welcome. So in part A, if you were doing order of operations, do you see that first, whatever you plug in, the first thing you do is you would subtract 2. So we can make that the inside function g of x. We can say the first thing we're going to do is subtract 2. Then after you've subtracted 2 and got an answer, what do you do next? You cube. So our outside function is cubing, and it says, well, whatever you have left, you're going to cube, so it's going to be x cubed. Imagine it this way. Here's your first machine. First thing you're going to do is subtract 2. That's your function g. And then, whatever answer you get, you're going to cube it. Can you see if you threw in an x, out would come an x minus 2. And then that x minus 2 would get cubed. And that matches our original equation perfect. So the idea of the composition of functions is sort of like thinking g of x is inside f of x. One function is inside of another function. So for B, can you see that the 3 plus x is inside of the square root? So your inside function would be 3 plus x, and once you've done your inside function, what do you do to the answer? You square root it. So our outside function is the square root of x. And in calculus, when we do derivatives, it's really important for us to notice when one function is inside of another function, because there's a whole set of special rules that we have to use in that situation. All right, questions for practice are 3, 7, and 9.